to this video. We're going to be doing section 11.2, sorry, ellipses. Alright, so here we're going to start with the geometric definition. So an ellipse is a set of all points in a plane whose sums of distance from two focal points f1 and f2 are constant. See this figure. These two fixed points are called foci, for focus, for the ellipse. So here, let's just start sketching this. So let's pretend we have a focus point here. Let's call this f1. Another one, let's do it the same. Notice that for the first three sections of this chapter, we're always going to be centered at the origin. Alright, so we'll just go ahead and draw our ellipse in. And so here, let's pretend we have a point here and a point here. So this distance here plus this distance here would be the same as this distance here and this distance here. So these two would add up to be the same. And we actually do this so it's nice and clean. So from here to here to here. So that distance would be the same from like here to here. So these two would have the same sum of distance. Okay. And so this ends up making the ellipse. And so we'll get into more parts of this in a second. So let's just go to the next section. Alright, so let's talk about everything we need. Alright, so the equations and graph of ellipse. So the equation of ellipse is centered at the origin still, has the following property. So the equation here, so we're always going to, so for the ellipses, A is always going to be greater than B, which is always greater than 0. So we have two ways. We have the A here to be greater on the x, or the A to be greater on the y. So which one of these two numbers is larger? This has to be a 1. If it's not a 1, please transform it to be a 1, okay? And for here, we'll have a plus sign for these, and so we'll have a plus sign for these. The reason we have plus means ellipse, the negation will mean hyperbola, and so we'll see that in the next one. Alright, so here, in this case, and so let's go ahead and draw these visual representations so it's easier to see as we do it all. Alright, so here we're going to have our vertices. And so here we're going to call this, and so this one's going to be a horizontal ellipse, this will be a vertical ellipse. And so here we'll have the horizontal, we'll have the vertical. So if it's greater on, if it's greater on the x, we'll have a0 be the vertice, and then minus a0 be the other vertice. Remember, because we're centered at the origin. Here, the other 2 points, in this case, will be 0b for the y, 0b, or 0 minus b, and for this one, we'll have 0, we'll have 0a, 0 minus a, and then b0, and then minus b0, and so it'll come up, down. Let me make this more pronounced, and so let me move in my b's. So let's put the b here. There we go. Okay. Alright, so here the vertices will be where if it's horizontal, be in the x-side, and if it's vertical here, so it'll be plus or minus a. So the major axis is the long axis of the ellipse, and that will be 2a. So it'll be, this is a here, and this is a here, so that's 2a. For the vertical, here it's 2a and 2a, and the minor axis is 2b, so b and b, or b and b, okay? The foci will exist at plus or minus c, and so here we'll just put that right here. So this is minus c, 0, this is positive c, 0, and notice since a is defined to be greater than b, this will be positive, and so you just take the square root of these two. Same thing here, we have a to greater than b, and so the foci here at 0c and 0 minus c. Okay. And so here's all the parts of the ellipse, and so, you know, the work we'll see is we'll give you the equation, you're going to find all this stuff, or we'll give you all this stuff, and you ask for find the equation, or we give you part of this stuff and find your equation. So you'll go back and forth. The only last thing we want to talk about, let's talk about definition of eccentricity. So here we have our two equations, and then the eccentricity is just the number saying how much is this away from a circle, really. So it's the same C we had before, the same A we had before, and so we just do that. So here, if E is really close to 1, it looks very much just like a normal circle. If E is closer to, say E is about 0.8, these approximations, it's going to be pretty oblong. And so the bigger, closer it is to 1, the longer this is. Okay? Alright, so let's get to the problems. Alright, so for each one of these, we're going to want to find the vertices, the foci, the eccentricity, and then determine the lengths of the major and minor, and sketch the graph. So basically, we're going to find everything. Alright, so the first thing I want to do is I'm going to take the square root of 25. So this already has a 1 here, and this is a plus. We know this is an equation of ellipse. So we're just going to take the square root of 25. That gives us 5. We're going to take the square root of 9. That gives us 3. And so we can rewrite this as x squared over 5 squared plus y squared over 3 squared equals to 1. Okay. So now we know a lot of our points. And so let's do 1, 2, 3, 4, 5 right here. 1, 2, 3 right here. 1, 2, 3, 4, 5 right here. And then 1, 2, 3 here. All right, so here we have our major. And so here, that doesn't look the same. 1, 2, 3, 4, 5. There we go. Now it looks the same. I can count. Okay, and so here we can determine everything. So our major axis is just 2. So the major axis, so the length of the major axis here is 10. The minor is 6. So 2 times this number, 2 times this number before squaring it. Alright, and then our C is equal to the square root of 25 minus 9, so that's the square root of 16, so this one's a nice clean number of 4. Alright, so our C here is 4, so our focus is right here and right here, so here are focal points, okay? And so here you can go ahead and draw in our ellipse. Here's our focal point, so our axis here is 5, 0. Our focal point here is 4, 0. Here we have it as minus 4, 0. And then we have here at 5, or minus 5, 0, sorry. So here's all our points. Here's our major and minor axis. And then for the eccentricity, so this is just A. So remember, it's just C over A. So here we're going to have C, which is 4, over A, which is 5. And so this is so this is 0.8. Okay, so now it's pretty oblong. I'm just double checking everything real quick. Sorry about the break. Yeah, so this is kind of oblong. And so here we've determined everything for that. Here, we're going to have to divide by 16, so I'll have x squared over 16 squared plus 4, oops, no, yeah, 4 over 16, which is just y over 4 squared equals to 1, because this has to be a 1. So it's not a 1, divide it out. Here, we're going to still have, this becomes x squared over 4 squared plus y squared over 2 squared equal to 1. And so here we have, so here we'll go over 4, 1, 2, 3, 4. Here we go over 4, 1, 2, 3, 4. Here we go up 2, 1, 2. We'll go down 2, 1, 2. And so here the major axis length is twice this number, so 8. The minor is 4. Our C in this case will be the square root of 16 minus 4, which would be the square root of 12, which is roughly What is that number? Hold on. I'm going to crunch it real quick. So I'm not guessing. It is 3.46. So roughly 3.46. And so it'll be right about here. And let me go ahead and draw this thing in. Alright. So here we'll have our vertices here at 4, 0, minus 4, 0. We'll have our foci at minus square root 12, 0, and square root 12, 0, or 3.6, right? And here, and the eccentricity of this thing would be 3.46 over 4. So let's crunch that number super fast. Divide by 4. And we get about 0.86. Actually, 87 if I do the rounding correctly. Alright, so let's go ahead and do the next two. So let's go ahead and move this over. So I'll have 2x plus y, 2x squared plus y squared equals to 1. Okay, so I have this equal to 1. So what is this divided by? That so here we can rewrite this as x plus y squared equals over a half. So here we take the square root of a half. So the square root of 1/2 is equal to 1 over the square root of 2. And so here we have 1 over square root of 2 and 1, right? So here will be about 0.7. So let me actually just stretch this out. So I'm going to use so each one of these is worth 2. That's still too small. Let's make each one of these worth 4. So 0.7 would be roughly here. So let's make this a 1 as my scale, and then here for my scale here, 1, 2, 3, 4. Let's make this a 1. Okay, so if we use this as our scale, the graph of it will be a little bit cleaner. And so here we have a vertical 1. Oops, let me go through the points correctly. Alright, so what do we have here? We have here, this distance here is 2 times square root 2, so the major is 1 by 2 of them, right? So major would be 2 times, this would be over 1 if I wrote it. The minor, so this is 1 squared, this is actually, I can write this as square root 2 squared. So the minor would be 2 times 1 over the square root of 2. I mean, yeah, you could simplify this as 2 over square root 2, and then you just get square root of 2. This is fine. Alright, our c is equal to 1 minus the square root, or 1 minus a half. And so c here is the 1 over the square root of 2. And so our eccentricity would be 1 over 1 over the square root of 2. Or just equals to 1 over square root of 2, which is roughly, remember, to be 0.7. I can get that number correct in my head, so 1 divided by SQR 2. Yeah, it was 0.707, so about 0.7 is good enough. So that's our eccentricity. Here we have our foci will occur at 0.7. So about 0.7 here, 0.7 here. So here's our foci. And so here we have our axis at 1 and 0. The foci will be at 1 over the square root of 2, 0. Here we'll have this to be at minus 1, 0 for our vertice, and then our foci will be at 1 over the square root of 2, 0. I know that's kind of hard to read, so that's why I'm saying it out loud. This is 1 over square root of 2 times 0, 1 over square root of 2 times 0. Okay. So the last thing we want to do for this set of notes is find the equation of ellipse whose major axis is 10 and the minor axis vertically. So we know it's 10 vertically, so 1, 2, 3, 4, 5. So here's 5 of it. Here's the other 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. So here'll be the other 5. And it'll be 2 this way, and then 2 this way. And so here we just want to go backwards and find the equation if I knew this, right? And so let's pretend I knew this point of 5, 0. Oops. That'd be, don't mind my dyslexia. This is 0, 5, and then 2, 0. Okay. So given this, could you figure out what the equation is? Yeah, sure, right? So we have x plus y squared over 1, and then this is some a and some b. Well, here I know this is 2, and I know it's over this, so this should be 4, and I know this is 25, right? Because here 2 squared is 4, or I guess technically I should write this as 2 squared over 5 squared, because this is, and so it's just, you just measure out this distance and divide by that number squared, right? So if this from the origin to the end is 2, it'd just be 2 over that for the x, and from here to that, it'd be 5 squared. And so that's all you need to do. This is actually, it's quite easy to go backwards. So you just say measure from the origin to the end of your ellipse. If that's 2 units, then just say 2 squared under the x, and then for the y, from that to the end of your ellipse in the y direction, it's just that, equal to 1. Okay? Alright, so that's the end of these notes, and so we'll call it good.